Welcome to ERC Tipsnology. In this video, we will be doing the mesh analysis of two voltage sources in a series parallel circuit. So, I will be doing the same example that we have done in the previous superposition theorem. Here, we will be using mesh analysis to find the current through the resistor R2. So, let's draw the circuit. As shown here, we have VS1 with a voltage of 7 volts, and we connected two resistors and one in the middle resistor. We call this R1, R2, and R3 with values of 1 kilo ohms, 500 ohms, and 900 ohms. And then on the right, I put here a voltage source number 2 of 14 volts. Now, to solve this problem, let's draw the circuit again, and let's put the values instead of 1 kilo ohm, we put 1000 ohms to make all of the resistors with the same values. And then we draw a loop inside the left side, and let's put some arrows in a clockwise direction. In this way, we will put too much arrowheads in order for us to clearly see the supposed direction of the current on the left side. And then on the right side, we will draw another loop, and we will draw lots of arrows to represent the direction of current I number 2. And then these are just assumed directions of the currents. Later, we will find out if the direction that we have chosen is really correct, and we will go back to that later on. Now, we have here I1, and what we do is we multiply the R1, which is 1000, to the I1. So, we will get 1000 I1, and then we will multiply plus 500 multiply with I1, but since the direction of I1 is going down and the direction of I2 is going up, we will subtract I1 minus I2. Again, the direction of I1 is down, the direction of I2 is up, so we will have different direction. We subtract I1 minus I2. Then when we go through the voltage source 1, we will enter in the negative, so we write minus 7 volts. And then we will equate it to 0. Actually, this is Kirchhoff's voltage law. 1000 I1 plus 500. Then we factor in the 500. We will have 500 I1 and the 500 I2. But then this is positive and this is negative, and so we will put here negative. Then we copy minus 7 equals 0. And you see here I1 and I1 have the same name, so 1000 will be added to 500 because both of them has I1. So we will get 1000 plus 500 I1 minus, let's copy this, minus 500 I2 minus 7 equals 0. And then we will get 1500 I1 minus 500 I2. And this minus 7 will go to the right. It will become positive. So we will get here from minus to positive 7. Again, this will look like 1500 I1 minus 500 I2 equals 7. And this will be the equation for loop number 1, or for the I1 loop. Now, let's focus our attention on the loop I2, or the second loop. So we will have 900 I2 plus, we will enter the positive of the VS2, so we copy plus. And then let's go to the clockwise direction. Going down, we have, after plus 14, we will enter the R2, which is 500. So plus 500. But the direction of I2 is going up. That would be up. But the other side is going down. So I2 minus I1, because it has the I2 has a different direction with I1, and of course the I2 will be the plus and the I1 will be the minus. That's why we got I2 minus I1. and both of them are sharing the 500 ohms resistor, and then we will equal it to 0, and we can cancel this voltage for the meantime, and we have 900 I2 plus 14 minus 500 I2, and we will distribute 500 to I2 I1 here, and this is positive, this is negative, so we will get negative 500 I1. Remember in algebra that if you have positive and you have a negative value, it will become negative. That's why we will have here plus 500 I1, and then that would be equal to 0. And let's see the common terms. I2, so 900 plus 500 I2, because both of them has I2, therefore we can add them, plus the constant 14 and minus 500 I1. Again, the constant must go to the right, so we will put the positive 14 later on the right. So this will be 1400 I2 plus 14 minus 500 I1 equals 0. Now, what we do now is we have to change our position plus 14 to the right, and so we will get 1400 I2 minus 500 I1 equals negative 14. But then the I1 must be the first, so we will write minus 500 I1 because I1 should be the first, and plus 1400 I2 equals minus 14. And there you go, we have the equation for loop number 2. So again, let's write it in red. 500 I1 negative plus 1400 I2 equals minus 14. That would be the answer for loop number 2. Now at this point, we can use the calculator to determine the values of I1 and I2. But let's put them together here on the left side, the two equations that we got for loop 1 and loop number 2. So let's rewrite it. 1500 I1 minus 500 I2 equals 7, and then the second equation is negative 500 I1 plus 1400 I2 equals minus 14. And there you go, you have the two equations. Now let's use the calculator. Let's push mode 5 to get the equation here, and then we have here number 1, a and x, b and y equals cn. That has two unknown variables, that's x and y. So let's use number 1, and let's put 1500 push equals or press equals minus 500 or negative 500, and then press equals, and then 7 press equals, and then minus 500 or negative 500 equals plus 1400 or 1400 equals, and finally negative 14 equals, and you will see the value of x, which represents the I2, and that would be 1.513513 times 10 to the minus 3 amperes. And there you go. That's how easy it is to get the value for I1. And for I2, just press equal sign. You will see the letter Y, which is minus 9.459459 times 10 to the minus 3. Of course, you don't really need to write all of the numbers. It depends on your preference if you want 2 or 3 decimal places. Now let's summarize our answer over here. So we have the current here, which we assumed going to the right, and let's call this IR1 so that we will not be confused with I1. And on here, in here we have IR3, or the current on resistor 3. And for this one, let's use another color. Let's use black or blue here. That's to represent the IR2. So again, this is IR2, this is IR1, this is IR3. Now, if we will write them, we have IR1 will be equal to I1 because they have the same direction, and IR3 will be equal to I2 because they have the same direction, and there's no other resistor there, or I mean voltage source. Now, but in R2, we have IR2 equal to I1. Let's assume I1 minus I2 because we assumed that the direction of I1 is going down and I2 is going up, and we got the value of 1.51. Let's round this up, 35, let's make it 4, and the other one, 9.459, let's make it 9.46 milliamperes, and let's subtract the two, 1.514 minus the negative 9.46 milliamperes. Again, the negative or minus negative, that would be positive. So we have 1.51 for negative negative, that will become positive, so plus 9.46 milliamperes, and we will be getting a value of, let's press this again to mode 1. Our calculator must be in mode 1, and then we will calculate it, and we will get the value of 10.974 milliamperes. Now, if you will remember, or you will look you will watch our other video, we also get the same value for IR2 using another method, the superposition method. So it shows that even if we use mesh analysis, we will still get the same answer. Now again, let's do the revision or review of what we did. We made two loops, I1 and I2, and we multiply 1000 I1 plus 500 I1 minus I2 minus 7, because we are entering the negative side of the voltage source 7, that's why it's minus 7, and we added the two I1s there, and we distribute the 500 I1 plus minus, that would be 500 I2 negative, and then we calculated this through our algebraic knowledge or knowledge in algebra, and we got the answer of 1500 I1 minus 500 I2 equals 7 in our loop number 1. Now for loop number 2, we did the same. We got 900 multiplied with I2 plus 14, because we entered the positive side of the battery of voltage source 2, and plus 500 I2 minus I1, because the I2 has upward direction and I1 has a downward direction. That's why we get I2 minus I1, and we distributed 500 to I2 minus I1, and we got 500 I2 minus 500 I1. And then by algebra, we calculated the values of the loop equation, and we got finally the minus 500 I1 plus 1400 I2 equals negative 14. And this will be our loop number 1, and this will be our loop number 2. And by calculation in the calculator using the, again, let's review, mode 5. Alright, and then press the number 1, because we only have two terms that we don't know, I1, I2, so we use number 1, and we substituted the values of X as I1 and Y as I2, that would be represented there, and the constant here will be letter C, and we will be able to get the value of X and Y easily, which will also be I1 and I2, and we got this answer, and this would be in amperes. And just to shorten our answer, the times 10 to the minus 3, again we can make it milliamperes. And so we round up the answer to 1.514 milliamperes, negative 9.46 milliamperes for our IR3. By the way, the negative symbol here does not really mean our answer is wrong, but it means that the direction that we think we are correct is really wrong. So if you think that the direction of the IR3 is to the right and you got negative answer, then the final answer of the direction will be the opposite, and that would be to the left. But the number that you got is also correct, or is still correct. Again, the number that you got is correct, but the direction that you thought is correct is wrong. So from to the right, it will be to the left. So the IR2 is of course going down, and this will be the final direction of currents. We only changed the direction of IR3 because we got negative. So IR1 is 1.514 milliamperes going to the right. IR2 is 9.46. We can cancel the negative sign, but we changed the direction to the left, not to the right anymore. Okay, so this is IR3, that would be to the left, and IR2, let's change this, which is 10.974, will be downwards. That's it. That's how to do the mesh analysis in this circuit, and we can finalize our answer in the first drawing, in the first figure. This is the final direction of IR3 to the left, not to the right. And this is going down. As you can see, this is the final answers, and I'm just writing it down, the values of our IR1, IR3, and IR2. There you go. That's how to do the mesh analysis on two voltage sources with three resistors connected in series parallel. I hope you learned something today. Thank you for watching. Please subscribe to our YouTube channel. We need your support. Thank you so much and have a nice day.